Okay, concept 2, operations with radical expressions. So our objective for this lesson is I can add, subtract, multiply, and divide radical expressions. So that is our objective for today. So by the end of this lesson, you'll be able to add, subtract, multiply, and divide radical expressions. Okay, so let's get to it. So, steps for adding and subtracting radicals. Take off my scarf I just got here, so. Okay, steps for adding and subtracting radicals. So, step number 1, simplify all radicals. This is what we learned in concept number 1. So we're going to simplify using factor trees and factoring out squares and cubes and stuff like that. Step number 2, identify radicals with the same index. Remember, the index is this little number right here. And same radicand. They have to have the same thing underneath when you're adding and subtracting. You can't add and subtract the square root of 2 and the square root of 4. They're two different things. Only these can be combined. Step number 3, for common radicals, add, subtract the coefficients, and keep the common radical. You're going to treat the common radical like a variable, so like an x or something. Just think of it as a variable. If that will help you understand that that's not changing. Those are the units in which we're working with. Okay, so let's see if we can do number 1. So simplify all radicals. So we need to simplify this first. 27 is not a prime number. I know I can divide that by 3. And I can divide 9 by 3 again. So since it's no index, we take the index and make it 2. So we're going to look for pairs of 2. Well, here's a pair of 2 3s. That means a 3 will come out. Okay? So that means 3 times 3 is 9. And what's left underneath? Square root of 3. All right, let's see if we can't simplify this 12. That's 2 times 6, 2 times 3. We want square roots, so we're looking for pairs of 2. There's 2. So 2 times 2 is 4, and what's left underneath? The square root of 3. Oh, okay, so now we have the same radicand. We have the same index and the same radicand. We have 9 radical 3's and 4 radical 3's. We're going to subtract 4 radical 3's from 9 radical 3's, and how many do we have left? 5 radical 3's. Okay, so I'm going to do 1, 2, and 3. You guys can do 4, 5, and 6. Or, here's what I'm going to do. I'm going to do 1, 3, and 5. You guys can do 2, 4, and 6. Yeah. Okay. Number 3. Again, simplify. So be careful when you're looking at these, because if you notice, these indexes are the same, but this one is not, which means at the very end, we're not going to add this to these. We're going to simplify this, but we're not going to add it because it's not the same index. So here we go. 2 times 24, 2 times 12, 2 times 6, 2 times 3. Okay, so our index is 4, so we're looking for groups of 4. There's a group of 4 2's right there. 2 comes out. 2 times 7 is 14. I'll bring it over here. What's left underneath? 3. Oh, it's the 4th root of 3, not the cubed root of 3. 4th root of 3. Okay, this one already has a 4th root of 3. So 14, 4th root of 3 minus 2, 4th root of 3. So we know we're going to combine those. So 14 minus 2 is 12. 4th root of 3, and then even though we can't combine this, we're still going to simplify it. So 2 times 36, 2 times 18, 2 times 9, 3 times 3. We're looking for groups of 3, so there's a group of 3 2's, so 2 will come out. So plus 2 times 3 is 6. What's left underneath the cubed root? 9. So this is our answer right there. Okay, and number 5. Woo! So looking for pairs of 2. So 298 divided by 2 is 49. Okay, I'm not going to go any further because I know what the square root of 49 is. It's 7. So that means the 2 is going to be left underneath. Remember, for exponents, I'm looking for multiples of 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. Okay, so that's that guy right there. This has a radical 2 in it, so this one's going to stay the same. Oh, look at that. 7x squared y radical 2 minus 3x squared y radical 2. All of this is the same in both, so that means I can combine them. So 7 minus 3 is 4x squared y radical 2. Okay, when you're combining, you want to look to make sure everything is exactly the same. All right, so that's adding and subtracting.